In 1961, mathematician and meteorologist Edward Norton Lorentz was running a numerical computer model to redo a weather prediction from the middle of the previous run. As a shortcut, he entered the initial condition 0.506 from the printout instead of entering the full precision 0.50617 value. The result was a completely different weather scenario. At one point he decided to repeat some of the computations in order to examine what was happening in greater detail. He stopped the computer, typed in a line of numbers that it had printed out a while earlier, and set it running again. He went down the hall for a cup of coffee and returned after about an hour, during which time the computer had simulated about 2 months of weather. The numbers being printed were nothing like the old ones. He immediately suspected a weak vacuum tube or some other computer trouble, which was not uncommon, but before calling for service he decided to see just where the mistake had occurred, knowing that this could speed up the servicing process. Instead of a sudden break, he found that the new values at first repeated the old ones, but soon afterward differed by 1, and then several units in the last decimal place, and then began to differ in the next to the last place, and then in the place before that. In fact, the differences more or less steadily doubled in size every 4 days, or so, until all resemblance with the original output disappeared somewhere in the second month. This was enough to tell him what had happened. The numbers that he had typed in were not the exact original numbers, but were the rounded off values that had appeared in the original printout. The initial round-off errors were the culprits. They were steadily amplifying until they dominated the solution. He originally used a seagull causing a storm, but was persuaded to make it more poetic with the use of a butterfly and tornado by 1972. This story is about the term butterfly effect, which is being used as a broad term for all situation where a small change is supposed to be the cause of larger consequences. We should learn from this example that the difference between success and failure starts with something trivial.